This is the week 5 review and reflect for Devbootcamp Phase 0. We're halfway through the curriculum. Second week of doing Ruby, which has been way crazier than the first 3 weeks of stuff we did. And let's start with these questions. All right, first section is about data structures. And the question is, why are data structures useful in programming? So data structures are basically like arrays and hashes, and it's a way of arranging multiple pieces of information, which you can then do things with. Ooh. So well, we're going to go into arrays and hashes in just a moment here. But since it's asking why are they useful in programming, it allows you to catalog a wide berth of information without having to like type out each variable at each time. And if you have a similar list of items, you can group them all together and then pull that up. So like if you had a library, it might be nice to have a section that's totally devoted to science fiction rather than just having every single book as a variable. And even like you'd want to put the library in a data structure. You don't want to just have like thousands of individual variables with no labels attached to them. So yeah, data structures makes it a lot easier to make sense of the data you have, but then you can also do different types of methods on them to like compare the data or to pull a specific kinds of files within the data that matches these specific qualifications. There's a lot of things you can do. The next section is arrays. So the first question is define array and describe the characteristic of an array. So an array is an index collection of information, and there's an integer index. But that collection of information, each piece of information is a single value. So like if you have a list of your favorite baseball players, well, I don't know anything about baseball players, so there's a terrible example because all I could think is like Cal Ripken, Babe Ruth, and Shoeless Joe Jackson. Let's say those are your 3 entries in this hash. Or not hash, in this array. Then the first one you put in, if it's Cal Ripken, that'll have an index of 0. The second one you put in, if that's Babe Ruth, will have an index of 1. And the third person, Shoeless Joe Jackson, will have an index of 2. And conversely, you could do an index minus 1, and that's going to give you the last value in the list. So that would be Shoeless Joe Jackson again, which is pretty awesome. So you can access the information in either direction. But if you're doing it from the front to back, 0 is what's linked to the first value. If you're doing back to front, -1 is what's listed for the last item in the list. And the other question they have about it is give 2 original examples of data sets an array might be well suited for. All right, you could have animals in a zoo. And in the array, you just list every single animal that is in the zoo. It could also be a grocery list. Like, what do I need to buy at the store? And it just lists every single thing you need to buy in the store. And that's the key, is it needs to be single pieces of information, though, like that's like easy to digest. So if you write like apples, milk, eggs, bread, each of those things are like one item. The next section is hashes, which is a little different, is why it's talking about a single item when talking about arrays. Hashes, the first question, define hash and describe the characteristics of a hash. All right, so a hash is a collection of unique keys and values. I was trying to make sure I was using the right term. Keys, that's the thing. So with the keys, you might have something where, say like year that Cubs won the World Series, and then the value would be 2016. And those 2 pieces of information would be placed together, and that's like one block of information in the hash. And the way it's generally notated, if you call up the hash that already exists, would it have the key, so like Cubs, and then it'd be an equal sign, and then a like lesser greater kind of symbol, creating what I think they call the hash rocket, which is just a cool name. But it looks like a rocket. I'll paste it onto the screen so you can see it. And then 2016 would be the value. And then if you call up that key, it's totally different from indexing with arrays. If you call up that key in hashes, like you sum up cubs, then it's going to give you, as a result, it will say 2016. The next question we have here is give 2 original examples of data sets that a hash might be well suited for. All right, so one of them would be like the winners of, well, you could do it 2 different ways. You could do it a collection of who won the World Series every year, in which case the keys would be each year, and then hash rocket to the name of the team that won. Conversely, the reverse of that would be, well, yeah, it wouldn't make sense to use a hash the other way now that I think about it. That'd just be kind of chaotic. You could, but it might even like turn into like you have an array inside the hash, because then it would be, if your key was, man, okay, I don't know much about baseball, but if your key was like a team name like the Cubs, then the value for it would be an array, would be the best way of doing it, of consisting of every single year they've won. So then if you type in Cubs, it would pull up all these years. But another example of a good data set that would work with hashes would be, well, I was talking about a library earlier. If you have a collection of books, it would be really neat to have something like, you could have the title of the book as the key. Then for the value, you'd put in the name of the author. Like, so it'd be really easy to link that information. Or you might want to do it the other way. The only reason, what's tricky is with keys is that you only want to have one version of each. So if you had the author name, and then you link that to a book, well then, what if they've written another book? Which is why I think the title hash rocket to author would make more sense for using hashes. Unless, again, you have an array for your value, in which case you'd have author, hash rocket, and then it'd be an array listing all the books they've written. And that was part of what we did this week, was we were putting hashes in arrays and arrays in hashes, until no man could name what was going on, except we still had to, because they had us call specific pieces of information. The next section is iteration. The first question is, why is iteration useful? So, which is funny, because I guess they don't even want me to define it, but basically, iteration is something you do multiple times, and it's a method oftentimes that will execute a task multiple times. So the times method is an iteration method, which is, it's exactly what it sounds like. You write an integer and then dot times, and you're saying this is how many times we're going to do this thing. And then you specify, like, do this. And that's where blocks come in. That would be a block when you describe what you're going to do those multiple times. There's also the each method, which works great with arrays. And that would be, you'd have the array and then dot each. And then you'd have to identify like some name for each single variable in the array. But you say, like, do to each piece of information, do this block of code. Do this set number of tasks on it. And hold on a second. Okay, sorry about that. For you, no time has passed. For me, I answered the door and talked to someone and all that good stuff. But to get back into this groove, we were on iteration, and specifically the second question, which is give an example of a real-life task that would require iteration if you wrote an algorithm for it. I think a good example here is if you had like a normal grocery list where you're like, every week at the start of the week, these are the supplies I need. But what you do is, like, maybe you don't use the products all at the same rate. So each week before you go shopping to restocking those supplies, you actually check your cabinets and your fridge to see if you already have it. And if you do, you don't worry about buying it. In which case you have like the master list you start with. It's like, these are supplies I always need every week. And then this is where the iteration comes in. For every single item on that master list, you will check it for it in the fridge and pantry. And if you have it, then you're good. But if you don't have it, then you're going to write on this new list of groceries to buy today, like for this, to use for this upcoming week. And then that would be each iterator. That's what I was going to say. The method each, where for every single item on that master list, you do check to see if you have it. Then that's where the whole block code comes in, which is going to be the next question. The block code would be comparing it against all the items you have. If you don't have it, then finally writing on the other list of things you do need to buy this week. So speaking of blocks, this is the last section entitled Blocks. Go figure. The first question is, what is a block? Which the short answer, a block is all of the code in between writing do and end. And that's it. That's what it is. But specifically, like when you use iteration, then what you're going to say, you would have the iterator, like say you're using each on an array. So the array has a collection of items. Then you're using each. And the next question is block parameter, so I'm going to just go into that now. With each, you're saying you're going to run the following block of code on every single item in that array. And then where does that block parameter come from? After the each, you have like the, I forget what they call it. They call it like the rocket or something. Pipes, that's what they call it, pipes. And I'll put it on the screen so you know what it looks like. And then in the middle, you just have a name for the variable that's being used. And by the variable, I mean that item in the array you're plugging through the block code. And then after do, so the parameter is like that specific piece of information. Then in the do section, you talk about like all the steps that are going to happen with it. And chances are you're going to use that item at some point in the block code. And that's where the parameter comes in, because you type that in. This is how the parameter fits in this specific spot. So like if you print the parameter, if it's really simple, if you just have an array each, and then you say do, then for the variable name, you just write item, why not? And then all the code says is print item, end, then it's just going to print every single item in the array individually as it goes through the code. But you can make it much more complicated than that, which is why it's so useful. And that is all of the questions for this week. So thanks for watching this video. Probably a prospective future student to DBC, where you've already been accepted and you're just trying to get ahead. And we're up to the, well, not the last week of Ruby, like the big assessment's 2 weeks from now, and we have an assessment I haven't done yet for this week tonight. But I'm really excited for Ruby week 3. Things are getting harder and harder. And have a good afternoon or evening or day or whatever's going on. Until next time.